Welcome to Multiple Choice Question 19 of the 2010 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of the CAS calculator is not appropriate for this question, as there's no way to input the information into the calculator. So for question 19, the graph of the gradient function f dash of x is shown. Which of the following could represent the graph of the original function f of x? So if we have the derivative function graph, then that tells us about the slopes to tangents on the original function. In particular, we're interested in when the derivative f dash of x is equal to 0, because we know that when f dash of x equals 0, we have stationary points on the original function. So there's a value of x that's negative when x is about 0, and a value of x that's positive where we'll have a stationary point on our original graph. So if we inspect the 5 options that we've got, we're looking for a graph with 3 stationary points. So D has 1, 2, 3 stationary points in the right locations, and E also has 1, 2, 3 stationary points in the right locations. All the other graphs only have 2 stationary points. Or for B, this isn't actually a function even, so it doesn't have any stationary points in the right spot. And C doesn't have the necessary number of stationary points. So that means we can cross A, B, and C off as possible options for this question. So next we might look for f dash of x, and for when it is greater than 0 or above the x-axis, because we know that that will give a positive slope on the original function, and a positive slope has a gradient that looks a little bit like that. So on our original function, we can identify this region as having a positive derivative value, as well as this region having a positive derivative value. So that means on our original function, we want positive gradients in those similar positions for x. So inspecting D, we have positive gradients here, and again in this direction. So that's when tangent lines drawn to those points would have a positive gradient. And it also fits with f dash of x being less than 0, which would give a negative slope, which is something like that. So on our derivative graph, that's this region and this region here. And on our original function, if we inspect D again, these values of x have a negative derivative value because their slopes are negative, and the same happens again here for the function. So that means that D is the correct option for this question. And from the examiner's report, we can see that this question was done fairly well for the exam, with 77% of students getting that question correct.